just going to get started here. So thank you guys for joining us today, and welcome everybody. Appreciate you guys taking time out of your day to attend. Today our workshop is all about CosmWasm and Rust, particularly CosmWasm and Rust explained in plain English. So you don't have to be a developer or have much technical knowledge to understand these technologies. One thing to note, you will not be doing any coding in this workshop, but don't be disappointed because the next 3 workshops we have over the next couple of weekends, you will have the opportunity to get your hands dirty with some code. So moving on, our speaker today is a coding guru and a core contributor to DAO and DAO Up. Our speaker today is Zeke, or Ikez on Twitter, and you've probably seen him around. He does wonderful things at DAO and DAO Up. Let's see. Timmy, am I missing anything?
I wanted to jump in with one extra thing, just kind of some clarification on what this workshop is. I know some people are a little bit confused about what Spark IBC is, and like some people think it's an educational thing. So in essence, this would normally, all of these workshops on these Saturdays would normally be a fundraising campaign that we would run and try and get people to donate to be able to pay awesome instructors like Zeke to donate their time and provide education. But people like Zeke were so awesome and wanted to help us launch with a bang that they just volunteered their time. So that's why there's no actual funding required for these. But yeah, some people are just a little unclear on how these fit into the overall Spark picture. And so I just want to jump in with that. But otherwise, I think you guys nailed everything. So take it away, Zeke.
Hey. Oh, yeah. Hey, everyone. So sorry to disappoint you. If you were really wanting to sit and watch me write code, or you were really wanting to, write code, we're not going to be writing very much code. We'll look at some code today. Today is an intro to Rust and CosmWasm. So my goal is that you walk away with this, understanding all of the, conceptual bits that need to be understood to understand how, to write smart contracts and to write Rust, right? So let's start with what we're going to talk about. Can you guys see my screen well enough? I think that's confirming that this is operating.
Yeah, looking good.
So what we'll cover, I've snuck in a bonus section. This says just enter Rust and CosmWasm, but there's a secret what is blockchain actually section that I snuck in. So we're going to start by talking about what a blockchain is, then we'll talk about what CosmWasm is. We'll finally talk about what Rust is, and then we'll sort of end with a ton of examples. So I like examples. So first, what's a blockchain? This is a blockchain. A blockchain is just like a series of blocks. So in this case, I have 4. This is a really small blockchain. Some blockchains have orders of hundreds of thousands of blocks. In our really small blockchain, there's blocks 1, 2, 3, and 4. The blocks aren't that interesting. Excuse me. What's interesting about blockchains is these little arrows that are on these blocks. Go to the next slide. And so these arrows are sort of attestations about past blocks. So in this case, block 4 is making a statement that it is block 4, and it's also using some fancy stuff called a hash we're going to talk about in a little bit. It's asserting that I am preceded by blocks 1, 2, and 3. And so let's say that I was evil. I'm evil Ikez. I have a different bad kid, that's my profile photo. And I was oh, I want to change block 2 to block 2A. Well, the blockchain would know, your funds would, hopefully be safe. Because the attestations that block 3 and 4 have made of hey, I'm block 3 and I'm preceded by blocks 1 and 2 are no longer valid. And so that's sort of how blockchains protect this. They sort of have this property of immutability where each block sort of makes an attestation about all of the previous blocks. So changing a previous block will invalidate ones ahead of that. And there's this huge, science of I don't know, what if block 2A actually is the correct block and I was being evil, I actually tricked you and 3 and 4 were the evil blocks. And, we have these really fancy consensus algorithms called proof of work and proof of stake and proof of authority to solve the problem of like what is the real blockchain. But this is sort of what you want to know. So I'm going to briefly aside, and I'm going to talk a little bit more about these arrows. If this is like too much, you can just ignore it. We're just going to kind of speed through. So the arrows, they're actually hashes. Hashes are like super cool. They're like the bedrock of like most things. They're like, it's like a good thing to know about, which is why we're going to talk about them. So a hash is a function that has like certain properties. And the word function means just like it's a thing that has behavior. The properties are, it's easy to go from some set of input to an answer, but it's hard to go from an answer to what input produced that answer. And then finally, that's a property that every input has roughly unique output or answers. So let's do a simple example. On my screen, I have the number 3. That is my answer in this case. Can we think of like input, i.e. math, that produces the number 3? And like put it in the chat, or I'll just say it. Like this isn't like really too much of a brain thinker. But like 9 divided by 3 produces 3. 6 minus 3 produces 3. 1 plus 2 produces 3, right? So there's a lot of inputs. It's hard to guess, given this output, the number 3, what input produced it. In this case, it was 1 plus 2. And so hashes sort of have this property. So this is a real hash. In this case, we're hashing the word real example. And we get out this like massively complicated thing. And so this is like, given this like giant string, the process of reconstructing the string real example from this weird output, that is the problem that people that want to attack blockchains have to solve. And, a bunch of math in theory tells us that it is really hard to solve this problem. So it's hard to attack blockchains. So that's the summary. The summary is blockchains are blocks with arrows. I'm like probably oversimplifying things here. And hashes make them really hard to modify. Sick. I'm going to talk about what's inside of a block. So this is where it gets closer to like what you may like know of or have seen before, is these things called transactions. And so transactions are what go inside blocks. And transactions, you're probably familiar with these. I'd imagine, I'm like guessing the audience here has like probably done something with a blockchain. You might have like waited for a transaction to complete on Ethereum before, or like waited much less long on a proof of stake chain. But what you may not know is that transactions actually have more than one thing inside of them. So in this case, our example transaction has like 2 messages inside of them. There's one that says Alice sends 10 Juno to Bob, and another one that says Bob swaps 4 Juno for USDC. And the check mark here denotes that this transaction has succeeded. But you'll also notice there exists a transaction in this block that has an X in it. This leads us, conveniently, because I wrote these slides, to our next slide, which is do or do not, there is no try. So in blockchains, on these transactions either do work or they do not work. There's no like maybe transactions. There's no like, oh, I kind of worked. But for an example of that, let's say this is our failed transaction. In our transaction, Alice sends 10 Juno to Bob, who initially has 0 Juno in all our examples. And then Bob swaps 11 Juno for US dollar coin. The swapping business fails because Bob doesn't have enough Juno to do that. And so as a result, Alice's sending 10 Juno to Bob like doesn't actually end up happening, right? Like there exists this transaction that's like Alice sent 10 Juno to Bob and then Bob tried to swap 11 Juno, but it fails and the whole thing rolls back. Alice doesn't lose her money, Bob doesn't get USDC, like we just go back to where we were. And this is like super handy for writing smart contracts and for dealing with this kind of stuff. So we're gonna like drill this in with examples and you're gonna have to respond to these. So pay attention. It's just it's cool. So let's say Bob has 0 Juno and Alice has 10 Juno. And I submit a transaction that says Bob sends Alice 1 Juno. Like 1, does this work? 2, how much Juno does Alice have after the question in the chat? 10. Yeah, nope, 10. Nope. Nope, nope, 10. Does not work. Alice says 10. Also, yeah, 10. Hell yeah. Okay, you guys are geniuses. You're gigabrain, 10,000 IQ blockchain programmers. Because, yeah, this, like, fails. That'd be silly if it worked. Like, it would just suck, right? Like, imagine if you could just, yeah, right? Like, it would, you know, if you could send these, it wouldn't work. No gas, that also happens. Lots of reasons this fails. Cool. Let's look at a trickier one, or a more tricky one. 10. You got it right. There's the answer. X and stuff. Okay, here's the cool one. Bob has 0 Juno. Alice has 10 Juno. Alice sends Bob 2 Juno. And in that same transaction, Bob swaps 3 Juno for USDC. How much Juno does Alice have after this transaction? Nice. Fail 10, fail 10. Anyone going for 8? Anyone want to guess 8? Any takers on 8? Oh, okay, there we go. We got 1 on 8. Another on 8. Okay, cool. So the answer, I kind of baited you by saying the 8 thing. It's actually 10 again. Right. So the first, exactly like D. Steber says, first part of the transaction is cool, but the second part of the transaction fails. And so going back to our property where we said transactions either do or do not, there is no try. If we look at this transaction where one worked, check mark, but the other did not work, because that's either do or do not, this transaction is a do not, which means no state changes are applied. Alice still has 10 Juno. Cool. So transactions are sick. Yeah, so this is a point of, right, so transaction in this case does not necessarily mean, there's like transactions and there are messages. And so the transaction holds multiple messages. In these cases, the messages being Alice sends Bob 2 Juno and Bob swaps 3 Juno for USDC. And this is like confusing for like the brain model sometimes. It's like, oh, I thought a transaction was just this one thing. But in reality, like transactions are this sort of sequence of messages and then committed to the chain as a transaction. But the TLDR is just like transactions can have more than one thing inside of them. No. So also the one broke dude making independent transactions from random peeps. No, you cannot do that, right? Like in practice, Alice, could not submit a transaction that says Bob sends 2 Juno. This is sort of a made up example. That's a great point. Like me person cannot just like spawn in a transaction that says like Alice is sending me Juno. So that'd be silly. So cool. I think this will like clarify as we keep going. These are really good questions. So in summary, what is a blockchain? It's this series of blocks. They contain transactions. Transactions are lists of actions. They either succeed or fail. And if any action in a transaction fails, the entire thing fails. Moving on past transactions, talking about the stuff you guys actually came here to do. What is CosmWasm? So CosmWasm is effectively like the one-letter sentence of what smart contracts and CosmWasm are. Is they're just like ways to make really cool stuff happen with transactions. So they kind of like take your transactions and then make them like super cool. So let's look at an example. Let's look at our earlier one that said Bob swaps 11 Juno for USDC. So in practice, if you want to do this, you'd probably go to like junoswap.com and you'd click on the USDC pool and you'd hit swap. And naturally, like under the hood, the like 10,000 IQ Juno core devs have not like written into the Juno blockchain the code to like do that swap. There's not like a specially coded Juno feature that lets you swap tokens for each other. That'd be silly. And then like, you know, what if like one of the stable coins that was coded into the blockchain like exploded, and then we'd have to like vote to upgrade the blockchain to like should change our swap function. And that would just like be bad. So we want better ways to do that. And for that, we have smart contracts. So in practice, when you go to junoswap.com and you submit a transaction to swap Juno for USDC, you're talking to a CosmWasm smart contract that's doing stuff. It's like receiving your 11 Juno. It's deciding on a price for that Juno, and then it's sending you US dollar coin back. And when you do this, like math happens. And also another message is spawned in. So now this transaction has like send 11 Juno to the thing, and the smart contract has taken that and put another message into the into the transaction that's going to send you USDC back. And finally, what is also relevant here is that this CosmWasm contract is written in Rust. So there's like a lot happening here. And sort of the goal of like this sequence of workshops that I think next weekend Callum will be doing one, and then I'll be doing another, is to like get to the point where we fully understand this. So stick around. But there's more. So I have more examples. We're not going to get that complicated. Okay. So like these happen all over the place. It's like, let's talk a little bit more about this. Like I send a message and then messages get like injected in. So say I execute a DAO proposal, and this DAO proposal is like doing a lot of stuff. So maybe it's like sending a message which creates a new sub-DAO, sending a message that funds that sub-DAO, sending a message that gives that sub-DAO control over the hackathon, and paying me money. A lot's happening here. Smart contracts take things in and make lots of messages as they come out. Yes, this example. Basically, what you need to get out of this is just like messages go in, messages come out. You like have that list of transactions, you put in one, and the contract adds a bunch more to like do a bunch of complex stuff that would be a pain to do otherwise. Yeah, I can make the slides available if you like them. I'm shocked. They're not really, I know my arrows don't match up at the bottom, so. So like, you know, that taking away your own risk. Okay, so I want to like conclude our like brief discussion of CosmWasm by saying like why it's good. Originally I was using a different word and not screw in this slide, but I decided, you know, we're very professional people. So why is CosmWasm good? CosmWasm will mostly not screw you. You will screw yourself still. I do this because we're all bad programmers, but it won't be CosmWasm. So that's good. That's a desirable property of systems we work with. These steps are as a question. So CosmWasm are predefined route/jobs based on the original request. So yes, that's basically what it is. You send in a request and then it does a bunch of other stuff in like a predefined way. Predefined though is kind of a strong word where like these things can be like really complicated, as you're probably aware. Like it's not like I send it in and then I like always get the same stuff out. There can be all sorts of weird, you know, contracts, calling contracts and like doing math. But yeah, they are like deterministic. You put them in, you get messages out. So cool. We talked about CosmWasm, why CosmWasm's good. I also want to give an example of CosmWasm being good, and then maybe we can open to some questions. So sometimes when you add two numbers on a computer, they explode and do something weird. This is called overflow. And so you might take the numbers 2 and 1, and normally you'd add those, and like earlier, you'd get the number 3 out. But like, they're not actually adding 2 and 1, but say these numbers were like really pretty big. Sometimes when you add them, they're going to overflow, which is where they get too big and just sort of blow up. The computer says, I don't really know what to do now. This is like too much number. I can't do anything with it. And so it like gives you back this like explosion emoji. And it's like, you don't know what this is. It's still technically a number. You could add stuff to it, but it's like really pretty much nonsense. And so CosmWasm, being our friend, when it sees this happen, is like, whoa, 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 this is bad. Stop doing this. Other things though, will just keep going. So think about like, if you were interacting with a smart contract that was like swapping your money for you, how would you feel if you, at least I would not feel good. If I sent money to that contract and one of these overflow things happened, and instead of like failing and being like, hang on, we got to stop for now, let's try that again. If it just kept going and then gave me back like some nonsense amount of USDC. And in practice, when these overflow happens, it's usually like the number gets too big and then it wraps back around and then becomes like 0 or something. So imagine if you like sent, you know, to get so much US dollars back, you'd be like a trillionaire. And instead of getting $1 trillion back, you just got like $0 back because, you know, the smart contracts were not taking care of you. So that's why we like CosmWasm. So they're like, you know, they'll still do that sometimes because people like are bad coders and writing code is like super, super hard. But it's going to happen less frequently, which is sort of why working with CosmWasm, one of the many reasons that working with CosmWasm is like super great. So cool. Let's like summarize and take a little bit of a rest break here and like see pulse check where everyone is. CosmWasm is a way to write smart contracts. the smart contracts can do really cool transactions and change the state of the chain. And CosmWasm smart contracts are written in Rust. For the watch part right now. Does anyone have questions about what has happened so far? Yeah, like the overflow with negative amounts. That's exactly the kind of stuff that like you just like would not want that to happen in your smart contracts. That's like not a desirable feature of smart contracts. They just like blow up. So cool. Was there a stack overflow bug with Bitcoin as well ages ago? I'm sure there was. I think that's like probably not smart contract related. Like it's probably just writing code's really hard related. But I do think the Bitcoin core is written in C++, which is not Rust and doesn't, so yeah, there's tools we can use that are less likely to do it ourselves. Is it close to what happened in the osmosis pool? The osmosis pool, I don't know, maybe someone is here from osmosis that knows this better than I did, but it looked like their problem was part 2 of this. Not that they're bad programmers, they're really good. They know exactly what they're doing. This is a joke. But I think their code just was miscalculating something. It wasn't an overflow as much as they just like had a logic error. Yeah, Reese knows it better than I do. Yeah. Someone should do a Spark IBC workshop on that bug actually. That'd be like super cool. Because I read the commit that fixed it and like didn't understand it. I'm not, don't really know how AMMs work very well. Cool. So any more questions before we go on? We've got we're doing well on time, and we've got a couple cool examples to get to, but I don't want to get into these until people are like, I confirm that I know what's going on. Okay. All right, let's go. Let's do it. Cool. What is Rust?
I think we have one other question coming.
Oh, nice.
Oh,
cool.
No, just a comment on the osmosis thing, I think.
Yeah, I agree. Silknet's Bosca. Yeah. Someone should do a workshop on that. Okay, cool. What is Rust? Rust is a programming language. CosmWasm contracts are written in Rust. I'm not going to spend a ton of time on Rust today because it's just things to learn, facts to learn. You just got to learn the list of facts to know what the syntax is for the language. But I'm confident you can do that without me just stating facts to you. So what I'm going to say about Rust, it's a programming language. It's really fucking good. And CosmWasm contracts are written in it. Seriously, Rust is the greatest language in the game. You should totally learn it. And tons of people will want to hire you and they'll write super, super good code. It'll be awesome. I'm not going to teach you Rust right now, but it's good for similar reasons like CosmWasm. It will not screw you, but you will still screw up because writing code is okay, so now we're going to start going through, we have 2 examples, and then we'll sort of, get, Solana uses Rust. That's an excellent question. Solana does use Rust, they don't use CosmWasm. That's because CosmWasm is a framework, it's a way of doing things. So in CosmWasm, you would say, CosmWasm send, .send money or something. And then the Solana method would have a Solana way of doing that. The CosmWasm way, I don't know. I have a lot of thoughts about Solana and CosmWasm. I think Solana is good. You can use Solana. It uses BPF, which stands for Berkeley Packet Filter. It has just kind of a different. I think Solana is pretty good. In my opinion, I think CosmWasm has made better decisions around usability. I find writing CosmWasm to be a lot easier than Solana contracts. I also think that CosmWasm probably has a slightly better security model. They're both really fast. They're both really good. I like CosmWasm more, I think, but that's a good question. Yeah, CosmWasm also has Go binding too, but I don't think you can write contracts in Go yet. I know they are working on it. There's people actively that are smart. They're actively thinking about it. Both Solana, yeah. So I guess both Solana and CosmWasm benefit from Rust only Only CosmWasm benefits from CosmWasm. So that's like good. Go bindings. You could technically write eventually CosmWasm smart contracts in Go, which is a different programming language. I don't really know why you would want to do that. I think a lot of people really do. So it's kind of happened. But yeah, anyway. So let's do this. Let's do our example. So I'm going to give you an example of a smart contract that we're actually going to look at the code for the smart contract that does CW20 tokens. Most of you here probably use CW20 tokens, like raw is a CW20 token. Pretty much every token on Juno that's not an IBC asset is a CW20 token. So we're going to actually look at the code that does this and sort of fit it into our transaction model. So let's say I wanted to send tokens between addresses. There's sort of be 3 steps. First, I'd want to subtract the amount being sent from the sender's balance. Then I want to fail if the sender does not have enough balance. So like in our earlier examples with Bob, if Bob's trying to send one Juno to Alice, we'd be like, no, you can't do that. You don't need a Juno. And then finally, I want to add the amount being sent to the receiver's balance. So I'm actually going to show you some code in this next slide. Get ready. Boom. Okay. So this is what you all here for, is actual code. It's what it looks like. So this is the code that does this. So we've got 2 things, 2 objects, and we're calling this update message. So the first thing we do is we set this balances piece of state, which is state on the chain. And we say for the sender, take the balance and subtract the amount being sent. And this check sub here also does our check. So we were saying we got to subtract the balance, and then we want to fail if the sender doesn't have enough. So what we do here is we say balances for the sender, subtract, and fail if there's not enough. Then we do the same thing for the receiver. So in this bottom block, we update it for the recipient, and we say add amount. It's just a regular plus sign. So my question for you, intrepid souls that are listening to this workshop, based on what you've heard today, if the second state update fails, will the first one still happen? So no, nice. So yeah. So like, and this is like insanely helpful, right? This is like so nice if we're writing smart contracts, because imagine if that wasn't the case. Imagine what this code would look like if it was like, okay, I've subtracted from the sender's balance. Now I'm going to try to add to the receiver's. Oh no, the receiver's balance didn't update. Now I've got to like handle that. I've got to say, if receiver balance didn't update, go back and re-add the initial amount to the recipient. It's like nonsense. Like, you don't want to have to like walk back up your step. And so that's like this whole nonsense. Like I promise you, all of the nonsense I was talking about like, oh, transactions are atomic and they either succeed or fail. Like, the whole reason we did that was so we could get here and be like, whoa, look, writing code is like so nice, because if things screw up, the whole thing gets rolled back. I don't have to do it manually. And so like, we've arrived, guys. We've arrived. Now we can start getting to the really cool stuff. So cool, right? Same thing as earlier. Do it or not, there is no try. In this case, if that second balance fails, the whole thing fails. So I've just literally taken our earlier slide and replaced the word trans. Okay. So now, wait. First, questions. Does anyone have questions? Does this make sense? Because we're about to get into like the final really cool part of this, and then you'll go to future workshops and learn a bunch of cool stuff. An important fact to know in these blockchains is that smart contracts can do literally everything you can. So you think you are special? You are not. Smart contracts, which in this slide, in this presentation, are cubes, can do anything. So if you think you can execute smart contracts, so can smart contracts. So those messages you send in, if you were like, oh, execute a smart contract can also make a message that calls it. And this is kind of the reason why like DAO DAOs are so cool. Like plugging DAO a little bit is like DAO DAOs are smart contracts. Because smart contracts are super powerful, they can do like Literally anything. Anything you, a human, can do on a blockchain, so can a DAO, so can a smart contract. So let's look at an example of like things smart contracts can do. It's like, say you wanted to like split money between two people. You could do that, or a smart contract could do that. So you could like send $2 into a smart contract, and it could split that money into $1 each and send that to two other people. And this gets even crazier. You can have layers. So you could say like, execute a DAO proposal, and that DAO proposal sends $2 to the earlier contract, which then splits that money, right? And so this could get like arbitrary complex. Like if I was like a really good slide maker, we'd have this giant fractal of like expanding cubes calling each other. So smart contracts can do cool stuff. So in summary, smart contract execution is like transaction execution. It either does or does not. Smart contracts can do everything you can, and smart contracts can call methods on other smart contracts. So for the final example, we're now going to write a flash loans program, knowing the information that we have. There's literally no more knowledge you have to know. So with flash loans, what we want to do is we want to loan some money to someone and want to fail a transaction where we lent the money and it was not repaid. So for people that don't know, a flash loan is like an interesting thing of, yes, smart contracts will take care of all the balances. They will do all this stuff. They can do everything. You could have a smart contract that calls itself. They can do all sorts of shit. So anyway, flash loans are like hybrid loaning, but they only work on blockchains. They take advantage of this like transaction thing. And what they do is they effectively say like, you can have as much money as you want for one block. And if at the end of that block, at the end of that transaction, if you don't pay that money back, we're going to fail the transaction and everything you did is going to fail. And so this gives us effectively like risk-free loaning to some extent. Like we can loan someone as much money as they, and as long as they repay it in one transaction, you can either fail or succeed that transaction and they don't put up any club. So let's look at how this works. So obviously our smart contract is going to want to have a method that's like you send in and you say, hey, send Bob a loan. And then ours is going to generate these messages. One of the messages is going to be send a loan to Bob, right? But there's kind of a mystery one. It's like, what do we do now to like make sure that Bob repays that loan? It's an important question, right? We need to make sure he repays it. So I'm going to suggest, well, what if we had this function, check balance is X? And anyone could call this on our smart contract. And if the balance is X, that method will succeed. And if the balance is not X, that method will fail. So if I said, if the contract had $10 and I called the check balance is X method on it for $9, the transaction where I called that would fail. And if it had $10 and I said check balance is $10, that transaction would succeed. So this is a method on this smart contract that's going to fail or succeed the transaction based on if its balance is actually X. So my question for you, intrepid workshop visitors, is could we, using these two things, what did we replace question mark with to make our flash loans contract work? It's kind of a hard one. And it's like, it can be pretty abstract. Yes, DM is a genius. Nice. I shouldn't have given that away. I should let other people answer too. But yeah, that's exactly what we do, right? So like, if we replace the question marks on our box thing with check balance is X, we can now fail this transaction if people don't pay. Which is super sick. Yeah, so check balance, great question. Explain again. Basically, when I started this flash loan contract, I was like, we're gonna need at least one method, one thing you can do with the contract, which is send Bob a loan. What I'm suggesting is we add another method. So in addition to saying, send a message to the contract saying, hey contract, send Bob a loan, you can also send a message that says, hey contract, check that your balance is X. And that method will fail if the balance is not X and succeed if the balance is X. And so for example, if the contract has $10 and I say, hey, check that your balance is $10, it's gonna be like, cool, I succeed that transaction. And if it does not have $10, it's gonna be like, not cool, I failed that transaction. And if we chain those together, so here's our example. Say I wanna send a $10 loan to Bob. The contract has $100 and the contract has $100. So what is going to be done is when I send a message to the contract saying send a $10 loan to Bob, the contract's going to generate two messages. The first one will send a loan to Bob, and the second one will check that our balance is still 100. So Bob receives the loan. Bob can do whatever he wants with that loan, but he must send it back because at the end of the transaction, we're going to fail or succeed that transaction based on if he has $100. Based on if the contract still has $100. So we're going to walk through that a little bit more. We call transactions, right? Let's look at like an example of using our flash loan contract that we invented after like one 30-minute workshop on CosmWasm. So say let's do this. So this is what our transaction looks like. Bob has 0 Juno, contract has 10 Juno. Our contract is going to send Bob 2 Juno. Let's say Bob requests a 2 Juno loan. Bob then swaps that 2 Juno for USDC. This like works, right? These X's are swapped. Swap these two X's. And the contract checks it as 10 Juno. This transaction will not succeed. The contract will still have 10 Juno at the end because when Bob did that swap, he did not send those tokens back to the contract. And so it checked, it said, do I have enough balance? And then it turned out, I do not have enough balance, failed the entire transaction. Yeah, great question. What if someone accidentally overpays another loan payback? That's a good question. That's actually a really good question. Yeah, what if like I lent 2 Juno to Bob and like Fred, just like sent 2 Juno to the contract? So the beauty of these transactions is like, so if we go like all the way back, we're gonna like take a long journey. So we look at our list of transactions in a block. The beauty of these is that like typically there'll be one initiator of this transaction. So like Bob will like say, give me a 10 Juno loan, and then everything in Bob's 10 Juno loan will happen like in the first purple square there. And then if someone else also wants a loan, they'll say, hey, like I would like a loan, and that'll happen in a different purple square. And so like when you initiate a transaction, like there's not going to be like someone else can't like sneak in and add other methods to that. You kind of get to play in your own like purple square universe. So like basically then Fred like can't pay back your loan in the same direction. Like Fred's got to do his loaning stuff in a different square. So like you're good and there's isolation and you're safe. I see more people typing, so we can do more questions. Yeah, no problem. So cool. This is actually like, I'm just gonna like wrap this up here. Like basically this is the end of my presentation. We've done flash loans. That's like as far as we're gonna go. Next. So basically in summary, blockchains are made of blocks. Blocks have transactions. Transactions succeed or fail, and smart contracts can do really cool stuff with transactions. So final slide, and then I'd love to just sit here and answer questions for as long as you. There's more to learn. Today we like speed ran everything we need to know to do flash loans and like actually collectively created flash loans. I was really nervous we wouldn't figure out this second transaction thing, but we did. So cool. And that's like, so basically now you have like every single piece of like conceptual knowledge you need to go write like the data of smart contracts. Like this is kind of like the basis you need, and you can now write smart contracts. But there are like facts to know. There's like, what are the syntax of programming languages? What are like the actual way that I dispatch a message from the CosmWasm? And happily for you, there are more workshops coming up. So if you find this interesting and you want to like really get into the sauce and actually walk through the flash loan contract, we're going to do that. So in my hands-on with CosmWasm Intermediate, there exists a program called CW Flash Loans. We're actually going to look at like the real code for flash loans. So yeah, really appreciate you guys coming. I'd love to answer questions. Purple square universe. Yep, transactions are purple squares. Yeah. Oh yeah, there's a 0 to hero on GitHub. Yeah, IRL examples of flash loans. Yeah, thanks for coming, guys. There is, but we'll talk about it. We'll talk about it next week. I actually have written this flash loan contract and written the. So when we, come to my next workshop, and we're actually gonna like see a UI and interact with the workshop. It'll be sick, and we'll get an IRL example of a flash loan, which will be cool. So professional, great presentation. That's funny. This is, I don't know. Yeah, it's great. Yeah, if you'd like to be unmuted. Yeah, there's the link. I can send a.
Yeah, we could go ahead and let people unmute themselves now. If people want to have some free form stuff. Cool, let me go change that.
Ask questions.
I know, just about to post a link, but if you want to find that doc from Callum, literally just search CosmWasm 0 to hero Callum, and it'll be like the first or second GitHub result on Google.
Yeah.
All right.
I just sent the actual smart. If people want to look ahead, I sent the actual smart flash loan contract in the chat. For DM's question, yeah, for sure. For the workshops, I think we're going to spend as much time as reasonable making these like easy-ish to like use. So definitely workshop setup will be like environment setup will be included. So don't worry about that. We'll like make it really nice. So you should totally come to that. So you got the flash loan thing figured out. So
remember, this was all recorded. We will get a link out probably by tomorrow. So if you guys know anyone who couldn't make it, make sure to share that around. And yeah, we have more events like this coming up for the next 3 Saturdays.
Yeah. Thank you so much, guys. This is so fun. I really appreciate you listening and asking good questions. Makes me happy. I love this stuff. So feel free to come to future sessions and keep learning. This is really fun. So we're gonna build some really this is like the beginning. We're gonna build some really cool shit later. So
you killed it, by the way, Zeke. That was like the funnest way to get into programming I've ever seen. And I've done a lot of like intro level things, and they've never quite clicked.
Yeah, I try to avoid the actual code. So yeah,
excellent job, Zeke. Thank you so much for coming on.
Oh yeah. Okay, there's no more questions. I'm gonna bounce. I haven't had coffee yet this morning.
No coffee.
Cool. All right, guys, thanks so much. The recording for this will be up soon. You won't be able to join back into this voice channel, but you will be able to open up the chat. So let's say you wanted to refresh your memory on a question someone asked or something like that. We're going to leave this voice channel in the chat here, and the chat will also be in the recorded video. So yeah, I guess that's all. Thanks everyone so much for coming, and hopefully we see a lot of you guys next week.
Ciao, guys.
Have a good weekend, everybody.
See you guys.